Thank you. Thanks, everyone. I see Dr. Ed Catmull. So welcome, Ed. I hope you liked what we cut of the long interview we had, but I'm planning to place the whole long 90-minute segment on also on YouTube or somewhere for people to access. So there are a bunch of questions already, and I request all the attendees to type more questions. One question from Dr. PK, is known by PK, is a professor at one institution. He is intrigued by you mentioning a few times that I made a few mistakes. If you are okay with it, please share one or two of them. Maybe it will help us not to repeat it if you are in similar situation, given that we have many PhD students in the audience and may listen to this video later also. What are the three qualities that you think PhD students should build during the PhD life to have lasting impact for the research? So there are two different questions. One is about sharing some mistakes. One is about advice to PhD students.
Well, at New York Tech, as I mentioned, I wanted to be a researcher. So I had some theories, and the theories were about how to manage. And my theory was that you only hire people who are highly self-motivated and don't need managing. And after I was there for a while, and I had a very flat structure actually, about 40 people under me, and I realized I'd made a mistake. Now some of my theories were correct, but that one, for instance, was just wrong. First of all, you can't always tell how highly motivated somebody is in an interview. But the more important thing is there are a lot of people who do great work. They just need to have some management. And as I left New York Tech, I realized about a third of my theories about how to run a research group were wrong. So when I started at Lucasfilm, it was like a do-over. And I adopted the view, which I still have today, that about a third of my theories about how to do things are just wrong. And I actually think this is important. Everybody would say, well, we all make mistakes, and we're going to have some errors, and nobody's going to claim to be perfect. But this isn't about being close. It's actually saying, actually, I'm more wrong than I think I am. And I think it's important for people to get there. It's like, I'm more wrong than I think I am. Because what it does is it opens you up to what others have and to what others see. So that was one of the lessons coming out of it. And some of the mistakes were like the individual decision that was made. It felt kind of like a general one or what's particularly useful here. But when you're doing something new, which fundamentally you're trying to do, it has been students coming out, you want to go out and do something new in the world, then one needs to have a mental image that, oh, we're just trying something new. I'm trying to get the picture right. I want my ethics right. I want to have make contributions. But if I come up with a sort of a goal or a contribution, it's by definition, it's loosey. And you don't really quite know exactly where it's going to go, which means that as you approach it, you're really approaching it almost tactically, which means you're going to make mistakes. By definition, you don't know what you're doing. And that's a good place to be, where you can do that and that it's safe to do it. And the other thing I learned early on, especially when I was starting off, is I didn't have a lot of credibility because I was new. And but what I found was that some people, after they went through their early phases, they forgot the problems that they faced when they were starting. And so one of them is, if you see something in your life or in your management and your work that you don't like, you sometimes don't have control over it. You have control over your own actions, but you don't always control your environment. But you should always learn from it. And even if you can't fix it, you'll learn it, because at some point later you'll be in a place where you can make different decisions.
Okay, I have a Another question from Parikshit, a PhD student, a little technical nature. Your insight into the simulation of motion blur instead of sharp edges was interesting. As animation matured, more and more physics must have naturally made its way into the simulation programs. Do you think needs to be more academic programs where optics, physics, and animation are studied together?
Well, interestingly enough, at Utah, there were two fields that were tightly integrated, which was image processing and computer graphics, which then separated because they were like different specialty in different departments. And then in various areas, they started to come back together again. But it was, I thought, extremely useful to have had that discipline of the image processing, which was different than that of generating the imagery. And you are correct that as we advanced in the field of computer graphics, then simulation became increasingly important. And so basically we hired PhDs in simulation and in physics, extraordinary people who developed some of the fundamental algorithms, as well as recognizing that we weren't just doing simulation because we had to control the simulation. So for instance, if you got the wind is blowing leaves around, well, you may want a leaf to land in a certain place. So what you need is something which is simulation, yet with a different kind of control or constraints, which aren't part of the programs that are written for simulators in other fields. So it's learning from one field, adding to it, publishing it. It goes back, and then frankly, people in other fields, they get interested because you got similar kinds of problems. And then you start to have joint papers. And every time you have this connection where two fields come together in a joint problem, you very frequently end up with some really interesting new approaches, new ways of thinking about things, and you open up new fields. And simulations come just a phenomenally long way. It's pretty stunning, really.
Yeah, there are a bunch of comments or questions on educating or teaching computer graphics. Computer graphics touches everybody, yet it is still not a compulsory subject in a computer science curricula today. Is computer graphics a solved problem? Should people be working on it? Are there scope for, as from an undergraduate student to get employment that's related to computer graphics that keeps them engaged in a fruitful way? Is computer graphics a solved problem? Because much has been done, a lot has been developed. Is there a lot of scope as an undergraduate student as well as a PhD student?
Well, the leading schools that I'm, of course, aware of, I know the faculty there and known for a long time, and the new faculty that's coming along, they keep coming up with new creative ideas. And there's a reason for it, though. And that is underneath this industry, so underneath a lot of industries, have been a few events that are, or not events, a few processes that have been basically exponential. So the most, the best known one is Moore's law. So here you got 55 years of an exponential increase, which is doubling every 18 to 24 months, and it's slowing down somewhat. But that's like this driving factor underneath. But then you've got the graphics cards, which came out of the games industry, which have increased at a greater rate and have enabled neural networking to become reality. So neural networking or neural networks, like virtual reality now being augmented reality, it's an idea that came up 50 years ago, and smart people were working on it, but there wasn't enough horsepower or processing power in order to really advance the field. Well, as a result of the increased processing speed that came out of chips being designed for the games industry using algorithms that came out of the graphics industry, we end up with enough processing to restart deep learning, and then which itself created industry. So you've got these processes. So not only do you have Moore's law, but you've also got the same exponential forces in driving down the cost of sensors. And then you've got a massive amount of data now because of the internet, more data than we ever had before. Like, what do you do with that? Now, the interesting thing is the reason that Utah was given the task of working in computer graphics. I mean, if it wasn't Utah, it was going to be somebody else. But they believed that computers are going to get to be a lot faster. And at some point, we'd have so much data, we needed other ways of seeing it. Well, we haven't stopped coming up with new ways of getting data. We haven't stopped this exponential process, and faster and faster, cheaper and cheaper sensors. So the need to visualize in different ways is continually changing. And that's the thing we should never forget in anything we're doing. We see these amazing changes. Well, they were a result of the confluence of a number of factors. And among these factors are frequently exponential processes that take place over some period of time. Exponential processes are not intuitive. I posit that it is actually quite, well, I'm not saying this right. Our ability to predict what is going to falls off rapidly when something changes by an order of magnitude. But we're in a field where a lot of things are changing by an order of magnitude every 4 or 5 years. So we can't draw big conclusions other than to say that in terms of graphics, like, yeah, there's still going to be need. we still have problems.
So taking off on that, there are also questions on current machine learning based methods which directly simulate or create some of these, faces, characters, deep fake, etc. They don't do any modeling in the conventional kind. They train a network to create very realistic looking characters or faces and scenes. Is that a threat or is it an opportunity? What's your view on that?
Well, it's like most technologies. Typically, if somebody advances something, one is looking for the positive side of it. And we frequently ignore the negative side. So, I mean, as an example, I remember years and years ago, as the internet was just starting to begin, people were making these predictions about how it's going to increase communication. Information will be more available around the world. You get better contact with people. And the thing is, that actually took place. But what they didn't predict, that we were also going to have toxic silos where some bad things happen and bad actors are there. And when I look at something like deep fakes, then obviously the reason you asked a question about threat is that we now know that they're just plain or bad actors who try to take advantage of something wherever it is. It's like a reality. How do we think about it? What do we do about it? I don't think there's anything about saying this that's going to stop this skill of making images look more and more realistic. But at the same time, in terms of simulation, something to say visually, you are right. The models themselves are built into the deep learning itself. That's not the same as the model of the real world. There are differences, and it's not uncommon for somebody to come up with something and extrapolate to something that it isn't. It is a phenomenally powerful thing, but it doesn't actually necessarily represent a model that will do some of the things we'd like to do. And I haven't even read a lot of people coming up with good models for good internal representations.
So one person, Vijay, says he enjoyed reading your book, Creativity Inc. I guess academic groups can also benefit by incorporating practices from industry. What are your thoughts on that?
Well, the I remember this is back when I was in graduate school. One of the professors left. He said he wanted to leave the cutthroat world of academia and go into the ivory tower world of industrial research. Sort of, he because he was frustrated with the bureaucracy which can happen in some schools. And I know the schools vary in how they do that, how they think about it. It has to do with the personalities of people. Uh, but I loved the environment that we had because we were um, asked to participate in a bigger vision and contribute to it. And we came up with our own contributions, and the students worked well with each other. And it actually made this rather amazing environment. And anytime I see people just really trying to solve a problem and making a contribution in the world or moving their field forward with excitement and sleeping on the computer room floor at night. Of course, they don't do that anymore. But I think that's good. And environments should be that. These are social environments also. You're working with people who are friends, allies, long-term colleagues, and that's a good place to be.
There's also a question on your role as CEO of Walt Disney Animation Studios or even Pixar. How did the transition from a first-hand animation person to someone who manages team of animators or creating movies? How does this transition take place? How did you feel about it?
I'm not sure I understood the question.
You moved from being a animation person to a CEO of Pixar or Disney later. How did this transition? How did it affect you? This transition?
Well, it happened fairly slowly, so I could observe the changes. And as I mentioned, from the interview that you had played, that originally my mental image of myself was as a researcher, and I didn't actually want to be the leader. But at the same time, I liked being in charge. It's like this, I'm almost like guilty because, well, it's nice to be in charge, but I didn't want the responsibility that came with it. But as I said, it was really interesting how you get people to work together in a way that everybody felt like it's their problem. That is, you're all working together. Well, that's an interesting problem. But I also noticed over time that as new people came in, and I had now published some papers and I had to get a reputation, that they treated me a little bit differently than the people I've been working with. And I thought, well, I think from an interaction point of view, I haven't changed that much, but the way they're treating me is different. So basically, I just realized this is that sometimes people respond to you as the position rather than as the person that you are. And they do that. It's like, not everybody does, but it's going to happen. But I could just observe that. And when I talk with other presidents of companies, some people are very aware of that process. That is, people are setting things up for them, or they're trying to say what the person wants to hear. And some people are not aware of the process. They're not aware that they're being managed from below, which I think is damaging to a company. But because I could go through it slowly, and I had enough failures along the way, I could realize that I was frequently deluded. I know some people who are very successful and they're deluded because they were too successful too fast. I think it's one of the things that made Steve great in the end was that Steve had a massive, or actually three significant failures. And because he learned from it, he became this completely different person. And and on the other hand, I've seen people shoot up like a rocket and they draw a lot of wrong conclusions from the process. Well, observing that's interesting too. So it isn't as if, I mean, for me, the technology was always really interesting and fascinating. And the fact that we were using it for storytelling was interesting. And the fact that we were, as a group of people and friends, making our own story as a company, that was interesting. There are a lot of interesting things in the world.
So there are a bunch of comments and questions on virtual reality. While realizing, the storytelling is the key aspect. What, aren't there special areas where virtual reality could be a great tool? Or more importantly, how do we use these new technologies, new medias like virtual reality? Now, who should develop a new storytelling paradigm that involve these technologies? Is the job of the new kind of directors, or who should be doing this, and how should they be thinking about it?
Well, I think the first thing you do is to step back and say that in the era of virtual reality, or the area, it actually is a fairly broad spectrum. It's like a space of possible solutions. In fact, your first question was, well, what's the future of computer graphics? Well, this is part of it. And right now, as you do virtual reality, there are some things where it works. You put on the goggles and you move around. But being in the most successful of them, you say, well, okay, when the sensors and the devices detect where your head are, get to the point where you don't recognize them or feel them, and you've got various other things to tie into the senses so that you can become immersed, then it will change the nature of what you can do. It'll change that space of solutions you can go after. And it's one of those things where that's definitely going to happen. Right? There's no question about it. I don't know exactly when or at what rate, because it's still on an exponential growth path. So one can with confidence say it's going to become more and more important. Now, what are the areas? Well, there are some places where they've been using it for a long time, which has to do with design work, because sometimes if you're designing something, you move your head around and you see it. In fact, when I was a graduate student at the University of Utah, we had a head-mounted display. There was an arm going up to the ceiling to decide where the head was. And I was out there pulling points to make a model in space. So there's an area of design work. And then there is, let's take another space like news. I've seen some cases where they went out and they gathered news using virtual reality equipment, and it's very impactful. In fact, the one area, a fairly broad area, is where the environment itself is the character. Then it's a pretty natural fit. So if you want to go into Harry Potter's school or into the world of Star Wars and explore the world, then you can do that. And you can do it today. And that's where the environment's the character. So of all these spaces, many of which are very important and have got a big future in front of them, one of the hardest problems is that of storytelling. Because storytelling is just that, it's like you are telling something. So storytelling is different than experiencing, and which is okay. So if you think about games, most people who play with games, there's a whole world, there's a language of using games, of basically physically, you've got a device that's like the language of your interfacing with this game. Most people still look at the games, even without, even if they have virtual reality, most people prefer not to use it. And one of the reasons is that the notion of 3D space is actually in your head. The amount of information that can come in your eyes at any one time is actually pretty low bandwidth. But it feels like it's a massive amount coming in But what it's really doing is it's relying upon the fact that we model the world in our heads, which is different than what uh, uh, deep learning is doing. So it's a different underlying representation. So you've got a small amount of information coming into an existing world you've got in your head. So frequently, you don't need to have another immersive device because you're largely immersed in it with a 2D representation. Now, will that change materially if the device becomes so light and with a little lag that it actually alters how we think about it? Probably, right? That's absolutely worth doing. So if one thinks about storytelling, then one to think of it in terms of, well, we haven't actually developed the language for storytelling in a virtual reality. So, but we should be experimenting with it. The fact that it's not a commercial market yet is not important. We're talking about research and development. Now, we tried something at both at Disney and at Pixar. And we had a problem is one of the lead artists basically shot down every idea for virtual reality because they couldn't answer the question of why it should be in virtual reality. So I was not, we had 90 proposals and we didn't do any of them. So I was not happy about that. But down at Disney, we actually didn't have any of the lead artists decide what the project is. We had the people who had the passion, and they're the ones that made a project, which is the most successful virtual reality project that I'd ever seen. And they were using the lighting and sound to guide the eye. All right, so that's a start, right? How do you let people know where to look? Well, if you think about it, when you walk into a room and it's full of people, you got all sorts of noise and stuff there, then with your brain and your perception, you decide where to look and why you're looking there. Okay, we can do that. With the current state of virtual reality storytelling, we don't really know. We don't have enough clues yet, and we haven't trained ourselves to do it. In addition, it's another example, in the early days of live action filmmaking, the pacing of films was very different than it is today. Now, one of the reasons is that as we grew up with it, our understanding of the language of film changed our sense of pacing. So if we see an actor go to a hotel door and open it, and then in the next shot, they're at the balcony in the hotel looking out. All right, so we cut 20 seconds out of it. And if we showed the 20 seconds, it'd be deadly boring. So everybody now knows this, and we all get the clue. So we all of a sudden find somebody is 40 feet away from where they were before. That's perfectly natural. We don't think anything of it. This is the stage we're at of figuring this out. And that's the job of researchers who want to do storytelling with computer graphics.
Yeah, so new ideas in cinematography or presentation or use of this technology have to evolve, and that will happen when technology is also more ubiquitous. It's in everybody's hands. So Ed, I mean, thanks for spending this time. I will end with a comment sent by one of our ACM India members. His 11-year-old daughter, Ahana, was watching the interview with him. And she is fascinated by your contribution, Ed's contribution to creating all the fascinating movies she has grown up with. She wants to thank you and the colleagues who made it. And I'm sure this sentiment is very universal. I would like to echo that myself with all the movies, starting with so one of the comments that one of my students told about your work is there is no pixel in an animated movie that is not touched by Ed's work. I mean, so you have been very foundational work you've done in making sure such fantastic movies are made, and also as part of Pixar and Disney. been involved, I'm sure, in many decisions that created specific movies, which all thrilled us down to the soul. So thank you very much for taking the time. I thank you from ACM India point of behalf of ACM India, as well as all the audience and the Indian computing community. You said in our conversation that you have visited India several times. Hopefully, in a year's time, when things clear up, we will have you visit us and have more face-to-face, more real interaction than over a screen. And I love the fact that you're wearing a Utah shirt. Maybe, good for Go Utah.
Yeah, that's right.
Thank you very much.
Well, thank you
very
so much.
Namaste.
Namaste.
Thank you.
Bye-bye.
Oh,